So we are starting chapter 6 today with the first section, 6.1. It's all about polygons. So our goal today is to identify and classify polygons. And then we're going to focus in on a specific type of polygon, a quadrilateral. And we're going to find the measure of the angles. So the first vocabulary word today is polygon. A polygon is a plane figure. Plane means flat, so not 3D. These are just 2D flat figures that are formed by 3 or more segments called sides. So things to notice, polygons have to be closed, so there's no like open space. All the sides are connected at the endpoints. Connected at the endpoints means that there's no overlapping of the sides. So if the sides are overlapping, it cannot be a polygon. And then notice all the sides are straight. So if you have any curved edges, it cannot be a polygon. So those are the things you want to look for a polygon. Diagonal is a segment that joins two non-consecutive vertices of a polygon. So let me just show you real quick. I'll just show you on that first one. If I told you to draw a diagonal, you just go from a side, a vertex to another vertex, not the vertex not right next to it. Like this wouldn't be a diagonal because that's a side. You have to go one more over, but you could draw like that one too, or like that one. And that one. So those are diagonals, but you don't really need to worry about those right now. Sides, those are pretty easy. Sides are the segments that form polygons. So like here's a side, here's a side, here's a side, here's a side, here's a side. And then a vertex, just like with triangles, the vertex is the endpoints of the sides. So where two sides meet, that's a vertex. Any questions on the vocabulary terms? I'm sure these are words you've all heard of. Anyone need more time with these? Alright, you also need to get these in your notes. This is how we classify polygons. We do it by the number of sides. So if it has 3 sides, we call it a triangle. We've been talking about triangles for months, so no one should get that wrong. If it has 4 sides, we call it a quadrilateral. You guys probably have heard the word quad before. Like quad cities, that's where 4 cities meet. Or like some people call four-wheelers quads. What's another one? Quad. Your quads, I think those are 4 muscles. Alright, a pentagon. Pentagon like the Pentagon in Washington, D.C. It has 5 sides. Penta means 5. If it has 6 sides, we call it a hexagon. The way I remember hexagon is the X. The number 6 has an X in it. Hex has an X in it. There's a new toy out called the hex bug. Have you guys seen those? My nephew has one. It's just a bug with six legs. Hex bug. Kind of interesting. Next one is a heptagon. That's 7. Octagon. People usually get that one right because the octopus has 8 legs. Octagon has 8 sides. 9 is a nonagon. 9 has 2 ends. Non. Kind of the same. A decagon has 10 sides. And then any more than 10, you just call it by that number gon. So let's say it has like 15 sides. You'd call it a 15-gon. Or if it has like 30 sides, you'd call it a 30-gon. Or if it had like 45 sides, it'd be a 45-gon. So it just helps us from making up like an infinite number of names. We only have a name for the first 10. Anything after that is just an n-gon. So however many sides with G-O-N after it. Alright, so get all those in your notes. Let me know if you have questions. Alright, so part A. Do you think that is a polygon? Any ideas? No, I agree. Why not? What's the problem? I'll give you a hint. It's up here and down here. Yeah, those aren't sides. They're curved sides. So no, because there are curves or curved sides. All the sides have to be segments. So that's a no. What about B? That's also a no. There's actually two reasons why. You can pick either one and say it's, first of all, the segments overlap. Anytime you have an overlap, it's a no. Or anytime it's not closed. So see how these sides are just kind of dangling out here? So that's going to be a no. So I'm just going to say not closed. It has to be closed. All the sides have to meet at the endpoints. You could also say no because there's an overlap. And then what about part C? What do you think? That's a yes.
When we say yes, do you want us to put what it is?
Not on this particular one because it doesn't say tell what type it is. But on the next one, yes, you should. Because the directions tell you to. Any questions on these three? Alright, here's example 2. So this is kind of what you were just asking. If it's a yes, I want you to tell me what type of polygon it is. If it's a no, tell me why. So I'll give you a few minutes to draw these and then we'll go through one by one. Yes, we're going to name the type. No, we're going to say why not. Alright, so the first one, it's kind of bluish gray up on the screen. Is that a polygon? Yes. If yes, what type? So you need to count the number of sides. 1, 2, 3, 4, 5, 6. If it has 6 sides, what do we call it? Hexagon. Good. Alright, the next one. It's like a beige looking one. Yes or no? Yes, it is. Count the number of sides. 1, 2, 3, 4, 5. 5 is a pentagon. Good. Alright, the third one? No. Why not? It's not closed. Alright, the Pac-Man looking one? No? Why not? Oh, okay, curves. Good. Purple one? This is another yes. 1, 2, 3, 4, 5, 6. 6 we already did. It's a hexagon. And then the last one. It's a no. What's your reason on this one? There's an overlap. Good. Alright, so basically all the ones that are in color are yeses, and all the ones that are just the sticks, the black and white, those are no's. Any questions? Alright, next we're going to look at quadrilaterals. So this is kind of like what we were doing last semester with triangles, where we'd say all the angles add up to 180. And we do like 180 minus the ones we would know. That would give us the ones we didn't know. Same thing here, but now, instead of adding to 180 for triangles, we're looking at quadrilaterals. And those actually add to 360. So write this in your notes. Quadrilateral means 4 sides. Anytime it has 4 sides, all your angles are going to add to 360. So this next example is where the calculators are going to come into play. So if you need a calculator, now would be the time to get it out.
You know the calculators on your iPhone?
So the directions here say find the measure of the missing angle. There's actually 2 ways you can set this up. Sort of the easy way and then the more mathy way. I actually prefer the easier way. What should these all add to? You just wrote it down? 360. So you can take 360, subtract the ones that you know. That'll give you the one that you don't know. Anyone have it? I think you get 105. Does that ring a bell? Okay. Good. That's one way to do it. That's sort of the easy way to do it. I'll show you the other way in case you want to be fancy. Whenever we don't know something in math class, we use a variable. So you could call that measure x. And then you could say, well, I need to add all of these together, including the one I don't know, and equal 360. So you could set up that equation and solve for x. You should still end up with the same answer. Alright, so it's up to you. I recommend the red way. It's just easier on a problem like this. But the x way works as well. What are your questions on number 3? Now the next 2 we're going to look at, you have to set up equations. So it might be good just to start practicing setting it up this way on the easy ones so that you can handle the hard ones. But again, that's up to you. Questions? Alright, here's number 4 and number 5. I'll give you a second to draw these pictures and fill in the angles. But on these, like I was just saying, you have to set up equations. So if you want to go ahead and try to set up the equation, if you get done drawing a little early, that would be great. Alright, any ideas what the equation's going to look like for number 4? Okay, so we can start with the 2x. What do I do with the 2x? I need to add what? the rest of the angles. The 50, the 118, the 84. When I add all those together, what should I get? What's the measure of quadrilateral? Always add to 360. Good. All right, how do I solve an equation like this one? What do you do first? Combine like terms. Can someone let me know what you get when you do 50 plus 118 plus 84? 252. That's going to equal 360. The next step would be to subtract the 252 from both sides. Can anyone help me out there? 2x equals what? $108. And then one more step to find x. What do I do? Divide by 2. Great. X equals 54. Now, if you want to check that, you just plug 54 in right here. 2 times 54, that makes that angle 108. And then you can add 108 and 50 and 118 and 84, and you should end up with 360. If not, you need to start over. Any questions on number 4? Now, number 5 is a little different. What do these boxes mean? 90. So, I need to start with the 11x and the 81, and then I'll have two 90s. And all of those should equal, what do they always equal? 360. Good. Alright, again, we can combine all the like terms on the left side of our equal sign. 81 plus 90 plus 90 is 261. Good, and that equals 360. Next, I would subtract 261 from both sides. So 11x equals 99. So x is 9. Again, if you want to plug it back in, check your work. If you plug it in here, you get 99. 99 plus 81 plus 90 plus 90 does, in fact, give you 360, so this answer checks out. What questions do you guys have? All right, I'm going to go ahead and give you your homework. So, looking at the 6-1 worksheet, let's talk about the bottom 3 real quick. Number 17, you are using the figure off to the right. It says, tell how many sides the polygon has and what type of polygon it is. How many sides does that thing have? 6. Now it wants the name. 6 sides is a... It's up on the board on that poster. Hexagon. Good. Great. Now the next question says, name the vertices. What are the vertices? Those are where the two sides meet. So two sides meet at point A, point B, point C, point D, point E, and point F. Those are all the vertices. Now, number 19 says name the sides. The sides are the segments. How many letters do we use when we're naming a segment? 2. So like AB would be a side. What would another one be? ED, good. Another one? What? CD is another one. Good. That's 3. We need 6. FA, good. You guys are kind of all out of order, so try to find the ones we don't have. We don't have FE and BC, good. That's 6, right? All 6 of them? Good, so those are the last 3 on the homework. We looked at examples like the other 16, so hopefully you guys can handle those. But if you come across any questions, just let me know. You have the rest of class to work on this. It is due when I see you tomorrow.